updates, you can join our Telegram channel. You can find this link below the description box. Otherwise, you can directly search in Telegram this name. You will get this channel. You can join this one. You will get here PDF, previous year paper, and other updates. Okay. So we will start. So first coming 2-3 videos, I am going to cover all mixed question according to your syllabus. We will cover all topics in this question, so you will get idea about sample paper how question will come. Okay, after that we will going to start like chapter wise. We will cover all the questions. So here number of 2 into 1 mux requires to implement 64 into 1 mux. So mux means multiplexer. The question comes from digital. So how to find this one? So here see the inputs 64 into 1 and 2 into 1. So using 2 into 1 mux we have to implement 64 1 mux. So for that what you will do, 2 into 1 mux means what? 2:1. Here this is 2 input and 1 output, and 1 select line will be there in 2:1 mux. So like that 2:1, how much 2:1 mux required to implement 64:1? For that you have to do 64 by 2 equal to 32. Again 32 divided by 2 equal to 16. Again 16 by 2 equal to 8, and again 8 by 2 equal to 4. 4 by 2 2, and 2 by 2 equal to 1. So like that you have to divide till 1. After that you have to add all 32 plus 16 plus 8 plus 4 plus 2 plus 1. So that is equal to 63. So 63 number of 2:1 mux requires to implement 64 into 1 mux. Okay. So here one trick is also there. You can follow this trick also. So this trick is only applicable for 2:1 mux. When input is 2:1 mux, means using 2:1 mux, if any question will come, then you can utilize this trick. And what is the trick? Like here they ask 64, we have to implement 64 into 1. So you can directly 64 minus 1, you will do 63. Again if they will ask for 8:1 mux, we have to implement using 2:1. So 8 minus 1, that is equal to 7. If may they ask 32:1, we have to implement using 2:1. Then 32 minus 1, that is equal to 31 mux we required. So this trick is applicable only for 2:1. Okay. So here how much? 63. So option D is our right answer. Next. So next, what is the question? There 3 T flip-flops are connected to form a 3 T flip-flops are connected to form a counter. The maximum state possible for the counter will be. So the total number of states or maximum possible in any counter is how much? Wait, total number of states or maximum possible in any counter is equal to 2 to the power n. Okay, where n is number of flip-flops. So here how many number n is given? N here 3 T flip-flop, means number of flip-flop here it is given 3. Okay, 3 flip-flop already given. So equal to 2 to the power 3, that is equal to 8. So 8. So maximum state possible of counter will be how much? It is 8. Option C is the right answer. Okay. Sometime they may ask largest number can be stored in a counter. Sometime the question will come largest number of any counter they can store. It is how much? 2 to the power n minus 1. Remember this one also. Next. A 4-bit serial in parallel out shifts register is initially set to 1111. The data 1010 is applied to the input. After 3 clock cycle, the output will be. So shift register. Shift register, there are 4 type of shift registers. Shift register. So there are 4 type of shift register. First is SISO, yani ki serial in, serial out. Then serial in, parallel out, and parallel in, parallel out, and parallel in, serial out. This is the 4 type of shift registers. Okay, in this question what they ask, serial in parallel out shift register, they are using serial in parallel out register they are using. And initially it says to how much, initially it's set to 1 2 3 1 1 1 1. Okay, initially this set to 1 1 1 1. The data 1010 is applied at an input. Input क्या है हमारा, input is 1010. Okay, input is 1010. Now at the third clock cycle, what is the output we have to calculate. So how it will shift, first this 0 in a first clock cycle, this 0 will come here, then this 1 will be shift here, again this 1 will be shift here, and this 1 will be shift here. Okay, in first clock cycle the state will be see like this. After that, in second clock cycle, this one we have to initialize this one. So this one will be initialized, then this 0 will come here, this 1 will come here, and this 1 will come here. Again in third clock cycle, this 0 will come here, then this 1 will shift here, this 0 will shift here, and this 1 will shift here. So after third clock cycle output, so after third clock the output will be look like this only, 0 1 0 1. So option B is the right answer. Okay, next, the SR latch is example of. Latch means what? Latch is a basic element which store 1 bit of memory element. What? It store 1 bit of memory element. For storing 1 bit we use latches. There are 4 type of latches: SR latch, JK latch, D latch, and T latch. 4 type of latches are there. These are the 4 type. Okay, next, N-type semiconductor is obtained by doping silicon. So N-type semiconductor is obtained by doping which silicon, the question is asking. So coming to semiconductor, there are 2 type of semiconductor. First is N-type semiconductor and P-type semiconductor. Okay, now how this N-type and P-type formed? So N-type semiconductor, when pentavalent impurities is doped with pure semiconductor, then N-type semiconductor formed. Pentavalent impurities means what? Pentavalent means in any element the outermost shell will which covered by at least 5 electron. So there will be in outermost shell 5 electron is there in any element. That element is called pentavalent element. Like for example, phosphorus, arsenic, antimony, and bismuth. These are the pentavalent elements. Same like P-type. What is P-type? In P-type trivalent impurities are doped with pure semiconductor, then P-type semiconductor formed. And this trivalent means what? Trivalent means same. In any element there will be 3 electron will present. Okay, for example, aluminum, indium, and gallium arsenide. Okay, so gallium. So these are the example of trivalent impurities, or P-type you can say. So what is the question here? Question is asking N-type semiconductor is obtained by doping silicon. So N-type is formed by which? Phosphorus. Option A is the right answer. A room has a fan with 2 switches. The fan can turn on by any switch regardless of the position of the second switch. Logic for a set of switches is equal to. Okay, the question is a room has fan with 2 switches. There are 2 switches is there. Suppose A and B, 2 switches are there. The fan can be turned on by any switch regardless of position of the second switch. So here the question is means anyone here, the fan can be turned on by any one switch. If anyone, suppose this is 0 0 0 1 1 0 and 1 1. So here he is means in this question, it's the question meaning is if anyone is on, this one is, sorry, this is 1, at least one is on, then it will what, it will, the output will be 1, yani ki it will be on. Or the condition is if same position is there, then it will off, like 0 0 is there, then it will off, 1 1 is there, then it will off. So this is the truth table for according to this question and logic. So this logic output, what is the truth table for this? This is XOR gate. So XOR gate, option C is the right answer. A logic family shows the following value. A logic family shows the following values: VOH equal to 5 volt, VOL is 1 volt, VIH is 3 volt, and VIL is 2 volt. The noise margin and high and noise margin low respectively. So noise margin high, if you calculate noise margin high, for noise margin high formula is voltage, output voltage high minus input voltage high. So what is VOH? VOH is 5 volt and VIH it is given 3 volt. So 5 3 equal to 2 volt. Then noise margin low, what is the formula? This is V input low minus V output low. So VIL, what is the value of VIL? It is 2 volt and VOL it is 1 volt. So 2 minus 1, that is equal to 1 volt. So noise margin high is 2 volt and this is 1 volt. That is means option A is the right answer. Now coming to next question, what will be the fundamental frequency of the following circuit if each inverter delay is 100 nanosecond? Okay, so fundamental frequency, what is the formula for fundamental frequency? Frequency equal to 1 by time period. Okay, frequency equal to 1 by time period, and this time period is 2 and TPD. The formula for time period in gates and all, it will be 2 and TPD, where n is what? N is number of gate, number of logic gates, and TPD is propagation delay. Okay, number of propagation delay. So here 2 number of gate, how many gates are there? 1 2 and 3 gates are there. So 3 into propagation delay, time propagation delay 100 nanoseconds. So it is 100 nanosecond means 10 to the power minus 9. So we can solve this one to this is 2 into 3 is 6 into, we can write this one 10 to the power minus 7. So time period is how much? Time period is T equal to 6 into 10 to the power minus 7. Now we have to calculate what? Frequency. Frequency equal to 1 by T. So 1 by 6 into 10 to the power minus 7 second, and 1 divided by 6 into 10 to the power minus 7, and we can write this one 1.67 into 10 to the power 6 hertz. We can write like that. So 1.67 and we can 10 to the power 6 means megahertz. So 1.67 megahertz is answer. Option D is the right answer. The band gap of silicon at 300 Kelvin is band gap of silicon. So if we talk about energy band diagram of semiconductor, so how it is? It will be like this only. this is conduction band, this is valence band. So band gap means what? The gap between conduction band and valence band is called band gap, energy band gap, or forbidden energy gap. Okay, so sometime they will ask question, mostly question will come like this only, band gap. They will ask band gap, energy band gap of germanium, silicon and gallium arsenide. These three question will come in, like if the question will come to band gap, this they may ask regarding germanium, silicon or gallium arsenide. So for germanium, band gap is how much? It is 0.66 electron volt. For silicon it is 1.12 electron volt. For gallium arsenide it is 1.4 electron volt. So you have to remember this thing. Question may come from anyone. So here they are asking for silicon. So for silicon it is 1.12 electron volt. Okay. Next, what would be gray code equal to the number of 14? So 14, we have to find the gray code. So first what we will do, this is 14, we have to find gray. Okay, we have to find gray code. So before that we have to convert this thing to in binary. So what is the binary value of 14? It is 1110. This is the binary value of 14. Now for binary to gray conversion, if we are going to convert binary to gray or gray to binary, we have to use XOR operation. Okay, we have to use XOR operation. So we have to know XOR truth table. So XOR truth table, what is the truth table? This is AB, means input, and this is output. So for 0 0 0 1 1 0 and 1 1, truth table is like this. Like if inputs are same, then it will be, output will be 0. So 0 0 means 0, 1 1 means 0, and this is 1 1. This is the truth table for XOR gate. So for binary to gray conversion, what you need to do? This is binary. What is the binary? 1 1 1 0. This is the binary code. Now you have to convert in a gray. So first this MSB bit is same. You have to write 1. Now we have to perform XOR operation between here 1 to 1. So 1 XOR 1, that is equal to, if 1 1, then it is 0. Now again we have to perform XOR operation between 1 and 1. So it will be 0. Now XOR between 1 or 0. 1 and 0 means if 1 and 0 is there, then output will be 1. So this is the gray code for this binary number. Okay. So the answer is option D. Suppose the question will come like gray to binary. You have to convert gray to binary. How you will convert gray to binary? We'll take same example. Like we have a number 0 0 1 0 0 1. This is a gray. We have to convert in binary. So how you will convert? Same, you have to write 1 0 0 1, and same this MSB will come same. It is 1. Now you have to perform XOR operation like this. This we have to perform XOR, means 1 XOR 0, 1 XOR 0, 1 and 0. 1 and 0 is, output is 1. Now again you have to perform XOR between this 1 and 0. This is 1. Now again XOR operation like this, 1 and 1, 1 and 1, 1 and 1, output is 0. So this is what? Binary number. Okay, binary. So it is same like our question here. So like this you have to perform binary to gray or gray to binary. The valence band and conduction band for a semiconductor are. The valence band and conduction band for a semiconductor are. So same we have to check in. See, this is energy band diagram for semiconductor. This is conduction band, and this is what? This is valence band. So the center part of conduction band or valence band is called what? Fermi level. It's called Fermi level. So the valence band and conduction band for a semiconductor is what? It's far apart for each other. Okay, or nearly this answer will be nearly to Fermi level. This is Fermi level, EF. Okay, Answer is nearer to Fermi level. Sometime question will may they ask for n type and p type. Generally question will come for n type and p type. Means for n type the position of Fermi level, and for p type the position of Fermi level. So for n type, what is the position for Fermi level? This is conduction band and this is what? Valence band. Okay, this is conduction band and this is valence band. And for n type, this is F. For n type, the Fermi level is always nearer to conduction band. Okay, for n type, the Fermi level is nearer to conduction band. Same like in p type, if they will ask for p type Fermi level position, then you have to remember, then Fermi level will be near to valence band. Okay, these two you have to remember. For n type, they will ask for n type semiconductor the position of Fermi level, then you have to mention nearer to conduction band. If they will ask Fermi level position for p type semiconductor, then you have to mention near to valence band. Okay, next, an amplifier has voltage gain and current gain. An amplifier has voltage gain and current gain of 10 and 100 respectively. The voltage, current and power gain is decibels respectively will be. We have to find voltage, current and power in decibels. Okay, so power equal to what? P equal to Vi. Okay, P equal to Vi. What we have given? Voltage gain and current gain. So we will find first power gain. Power gain, voltage gain and current gain. What is the value? Voltage gain, it is 10, and current gain, it is 100. Okay, it is it's given in question, so we can write this thing 10 to the power 3. So power gain is 10 to the power 3. Now we have to find voltage gain. Okay, what we have to find? Voltage gain, current gain in decibels. So we have to convert these gains in decibels. So for that, what we have to do? So for voltage gain, if we want to convert in dB or decibel, then we have to use 20 log V. 20 log V. Okay, 20 log voltage gain. So 20 log voltage gain. What is the voltage gain? 20 log, it is 10. So voltage gain, it is given 10. So you have to write 10. So what is the value for log 10? For log 10 value is 1. So 20 into 1 equal to 20 dB. Now this what? Voltage gain in decibel is dB. Okay, same like current gain. Current gain, if you want to convert in decibel, then same 20 log current you have to use, current gain. So 20 log, what is the value of current gain? It is 10 to the power 2. Okay, now we have to use here one simple formula, log 10. Log 10 to the power 2, we can write this thing 2 log 10, like that we can mention. So 20 into 2 into log 10 equal to 1, that is equal to 40 dB. So it is what? Current gain is 40 dB. Now we have to also convert power gain also. Power gain in dB. Same we have to formula is 20 log power gain. Okay, so 20 log power gain is how much? It is 10 to the power 3. Just now we have calculated here 10 to the power 3. Okay, so 20, we can write this thing 3 log 10. So 20 into 3, it is 20 into 3 log. Okay, it is 60 and into 1, so 60 dB. How much it is? 60 dB. So it will come 60 dB. Sorry, for power gain. For voltage gain, formula is 20 log voltage gain, and for current gain the formula is 20 log current gain. Okay, but for power we have to write 10 log power gain. it is 10 log power gain, so it will come 30 into 1 or 30 dB. For power gain we have a formula, this one, 10 log power gain. Okay, so power gain is 30 dB. Voltage gain how much? 20 dB, 40 dB and 30 dB. So 20, 40 and 30, it is option B is our option B is the right answer. Next, circuit used to shift DC level of the input signal is. So circuit used to shift the DC level of input signal, it is clamper. Okay, clamper consists of one capacitor, diode and resistor. This is clamper circuit. Okay, clamper consists of capacitor, diode and resistor. Okay, it used to shift the DC level, and two type of clamper circuit are there, positive clamper and negative clamper. Same if we talk about clipper circuit, then clipper circuit is consist of one diode and resistor. Clipper circuit is consist of one diode, this is the answer. Okay, option A is the answer. One diode and resistor, this is clipper circuit. Clipper circuit is used to clip positive half cycle, positive cycle, or it will clip positive cycle or negative cycle. Either positive cycle it will clip or negative cycle it will clip. And this is also two type, positive clip cycle, positive clipper and negative clipper. Okay, here if we talk about rectifier is used to convert AC signal to DC signal. Okay, and amplifier, what is amplifier? Amplifier, it amplify the magnitude of input signal. Okay, coming to next question. BCD equivalent of 3, 4, 5. Okay, 3, 4, 5. One BCD is given, one decimal number is given. We have to convert in BCD. So BCD binary coded. BCD means what? Binary coded decimal number. What is the range of this? 0 to 9. Range is 0 to 9. And if you write the code for 0 to 9, it will be 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, then 0, 1, 0, 0, 0, 0, 1, 0. This is 1, then 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Then it will come 1, 0, 0, 0, 1, 0, 0, 1. This is till 9. So this is the code for 0 to 1. So for conversion of this decimal, what you need to do, directly 3, 4, 5, and you have to write corresponding codes. For 3 it is how much? This is 0, this is 1, this is 2, this is 3. 3 is 0, 0, 1, 1. Then 4, this is 4. So 4 is 0, 1, 0, 0, and 5, this is 5. 5 is 0, 1, 0, 1. So the conversion of BCD is 0, 0, 1, 1, 0, 1, 0, 0, and 0, 1, 0, 1. That is option C is the right answer. Okay. Next, which of the following is not a standard input test signal? So for testing of signal, for testing of standard input test, we are using impulse signal, ramp signal, and step signal, not speech signal. So here speech signal is the right answer. What does point A in the below circuit? This A, this point, what is called in this? This is known as what? So in any circuit, two or more element like resistor, capacitor, or inductor, they are joined together or they are connected, is called node or a junction. Node or junction. Option A is the right answer. Ebers-Moore model is applicable for what? Bipolar junction transistor. It is used in reverse bias and forward bias, and also in saturation region we can use this thing. Bootstrap loader code is the bootstrap loader code. Bootstrap loader is a one type of programmable programmer. It is used in EPROM or PROM, means non-volatile memory. It is used in non-volatile memory, and it is used to first code when machine is initialized. It is used in first code when machine is initialized. Okay, it is used first in BIOS. BIOS. BIOS means what? Basic input output system. Okay. In a positive feedback control system, the feedback signal is with respect to the signal. Okay, so feedback signal means what? Feedback signal is a signal. Feedback signal is a means output signal. When output signal, feedback signal, what is the work of feedback signal? It feeds the output signal in an input. It feeds the output signal in an input to produce error signal, which drives the system. There are two types of feedback system. First is positive feedback system and negative feedback system. Positive feedback system is regenerative. For positive feedback system is regenerative, and negative feedback system is degenerative. Okay, degenerative. And positive feedback system, positive feedback signal is always in phase, always in phase, and this is out of phase. This is out of phase. Okay, this is out of phase. So here they are asking about positive feedback control system. So positive feedback control system, the feedback signal is always in phase with respect to input signal. So option C is the right answer. The ratio of the amplitude of modulating wave to the amplitude of carrier wave is called. So the ratio between what? Ratio of amplitude. Ratio of amplitude of modulation. Ratio of the amplitude of carrier wave. So this is called AM. We can write AM or AC, carrier and modulation. Modulation and carrier. Okay, we can represent this thing by mu. This is called modulation index. Option D. This is called modulation index. Okay, so this ratio is called modulation index mu. One thing you can remember also, because so many time it will ask in question, modulation index varies between 0 to 1. So this question will come so many time. Modulation index varies between 0 to 1, and other thing also, like if mu is less than 1, then AM wave means AM wave is called under modulation. Okay, under modulation. And if mu is greater than 1, if modulation index is greater than 1, then it is called over modulation. And when mu is equal to 1, when mu is 1, then it is called perfect modulation. Then it is called what? Perfect modulation. Stands for RISC stands for, it is stand for reduced instruction set computer. So there are two instruction set in a computer, RISC, RISC, and CISC. So RISC is reduced instruction set computer, and CISC is complex instruction set computer. Okay, the RMS value of the voltage y of t equal to 3 plus 4 cos 3t. So y of t equal to 3 plus 4 cos 3t. Okay, we have to find RMS value. So this 3 here, this 3 is called DC value, and this is a sinusoidal value. So we have to find RMS value for this sinusoidal value. So how we will find this RMS for this sinusoidal value is RMS equal to Vm by root 2. Vm is how much? This is 4. So 4 by root 2. This is RMS value for this sinusoidal value. Now if we find u of t, RMS value for RMS value for u of t, then the formula is u of t equal to root under this 3 whole square plus this value 4 by root 2 whole square. Magnitude we have to take square under root square of magnitude. So 3 is 9 plus this is 16 by 2, or we can say this is 8. So 9 plus 8, that is equal to root 17. Okay, and root 17 volt is our answer, option A. Option A is our answer. Okay, next. A carrier is simultaneously modulated by two sine wave having modulation indices of 0.4 and 0.3. The total modulation index will be. Okay, so here already we have given mu1 equal to 0.4 and mu2 equal to 0.3. We have to calculate total modulation index, that is mu t, total modulation index. So total modulation index is square root of mu1 square plus mu2 square plus mu3 square plus mu4 square, or dot 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 whatever given indices. So here we have given mu1 and mu2, so we will take mu1 is 0.4 square plus 0.3 square, that is equal to 0.16 plus 0.09 or root under 0.25, and we can write this one 0.5. So option B, 0.5 is the answer. Which of the following is a digital transducer? Transducer means what? Transducer means which converts one form of energy to another form of energy. Okay, and digital transducer is used to convert analog signal to a digital signal. So in this option, encoder work is convert analog signal in a digital binary form. Okay, so here in the option encoder is the answer. The element which are not capable of delivering energy by its own are known as. So if we talk about this active element and passive element, active element is what? Active element is capable to deliver energy. Active elements are capable to deliver energy, for example voltage source, current source and transformer. So these are elements which are capable to deliver energy. If we talk about passive element, so passive element are not capable to delivering energy, like RLC. Resistor, inductor and capacitor are not capable to deliver energy. So here answer is option D, passive element which are not capable to deliver energy. Next, consider the following figure below is equivalent to. This figure is equivalent to what? So in this figure, if we see, this is what? NOR gate. This is NOR gate and this is the symbol of NOR gate. Okay, so input is A. What is the output for NOR gate? This will be A bar, this will be B bar. Again, what it will here input is A bar, here input is B bar. So the output what it will come? A bar plus B bar ka whole bar, like this it will come. Now if we solve this A bar means A bar plus B bar ka whole bar, if we apply here De Morgan's theorem, then it will come A double bar dot B double bar. Okay, and we can write this one A dot B. So this is what? This is AND gate. This is AND gate. Okay, this is what? This is AND gate. So option C is the right answer. Next, a current is said to be direct current when direct current means DC current. DC current the magnitude remains constant with time. The magnitude of DC current magnitude is always constant with time. Option A. If we talk about alternate current AC signal, if we talk about AC signal, Then in AC signal, magnitude and direction which changes with time. Okay, this is about AC signal. So here the answer is option A, magnitude remains constant with time in a direct current. A multimeter consists of, multimeter. What is multimeter? Multimeter is a measuring device. So multimeter, when it can measure voltage, it can measure also voltage, so we can say it is a voltmeter also. When it is used to measure as a current or ampere, then it is called current meter, and it will measure resistance also, so it is called ohm meter. So all the way above, here multimeter can used as a voltmeter, current meter and ohm meter. So option D is the right answer. If R1, R2 and R4 equal to R and R3 is 1.1 R in the bridge circuit shown in the figure, then the reading in the ideal voltmeter connected to AB is. So here AB means this one, this voltmeter. What is the value of this voltmeter they are asking? So what is given? R1 equal to R, R2 equal to R, R4 equal to R and R3 equal to 1.1 R, like that it is given. So how we will find? We have to find this voltage, yani ki VAB we have to find. VAB we have to find. How we will find? We can directly VA minus VB if we will do, then we will get the answer. So how we will go? How we will get this VA and VB? So for that we have to apply voltage divider rule in VA. If we apply voltage divider rule in VA, then how we will write? This is volt, how much? 10 volt. So 10 into R2 divided by R1 plus R2. Okay, or 10 into R2 is R, R1 is also R, this is also R. So this is equal to 10R divided by 2R or 5 volt. So VA is 5 volt. Likewise we have to find VB also. So VB, we will apply voltage divider rule in VB. VB is here. So now voltage is 10 into R3 divided by R3 plus R4. So 10 into R3, R3 is how much? 1.1 R divided by 1.1 R plus R4 is R. Okay, so this is 10 into 1.1. So we can write 110 R divided by, we can write this thing, sorry, we will calculate first this one. 10 into 1.1 R divided by this will be 1.1 and 1.1 R plus R equal to 2.1 R. This R and R cancel, this point we can cancel, so we can write 10 into 1 yani ki 110 divided by 21, like that we can write. Okay, and 5.23, if we calculate it will come 5.23 volt. Now we have to find, what we need to find? VA minus VB. So VAB equal to VA minus VB. VA is 5 volt minus 5.23 volt. So minus 0.23 volt is the answer. Option B is the right answer. Okay, which of the following is not we have as a transducer? Again transducer is same, which convert one form of energy to another form of energy. So in this option, which is not we have, which is not going to convert anything. If we talk about encoder, encoder is used to convert analog to digital. It will convert analog to digital. Okay, and decoder opposite digital value to analog value. It will convert digital value to analog value. If we talk about rectifier is, it will convert AC signal to DC signal. Okay, but this transistor is not going to convert anything. It will only magnify the input signal. So option C is the right answer. Okay, according to the algebra logic, A plus A bar generates. A plus A bar means what? So simply we have to check by, if we put a equal to 0, if we put a equal to 0, then a plus a bar means what? A plus a bar equal to a is 0, or a bar, if we put 0 bar means 0 plus 0 bar means 1, so it will come 1. Again, if we put a equal to 1, then it will come a plus a bar means 1 plus 1 bar, so it will come 1 plus 0 and 1, or plus, this plus means what? Plus means or, 1 or 0 means it will be 1. So in both case, if we put 0 then it will come 1, if we put 1 then it will come, so it will always 1. So option B is the right answer. Okay. Now coming to next question. Regulator IC 7905 provides regulated output voltage. Regulator IC is used to provide regulator output voltage. So there are two type of regulator voltage IC is there. Positive regulator IC and negative voltage regulator IC. So in a question, if they may ask, two series are there, okay, 78 series and 79 series. So these two type of ICs are there, okay. So these two type of IC are there. When it will start with 78, then you have to remember it is a positive regulator, okay. When it will start with 79, then you have to remember this is the negative regulator. Suppose the number is 7805, then it will give positive 5 volt output, okay. When suppose number is 7809, then it will give positive 9 volt. Suppose 7812, then it will give positive 12 volt output, okay. And for 79 series, same, 7905 is there, then negative 5 volt. 7909 is there, then negative 9 volt. 7912 is there, then negative 12 volt. Like that it will give output, okay. So here 7905 means this one, so minus 5 volt, option D is the right answer. The above circuit acts as, this circuit, what is how it will act, okay, this circuit. So if you see this transistor symbol, this is what, this is PMOS, and this is what, this is NMOS, okay, this is NMOS, okay. This arrow is going inside, so PMOS, this arrow is coming outside, so it is NMOS. So combination of NMOS and PMOS is called CMOS, okay, it's called CMOS. CMOS means complement metal oxide semiconductor, okay. This is what it is called, CMOS circuit or inverter circuit, okay. This is what CMOS circuit or inverter circuit, option D. For a zero mean wave, if the RMS value is 100 volt, what is the peak to peak amplitude, okay. RMS value, how much it is given? 100 volt. So Vm equal to what? Vrms divided by root 2, or Vrms equal to Vm root 2, okay. We can write like this, sorry, Vm, wait, this is wrong formula actually, we have to erase first this one. Okay, now Vrms equal to what? Vm by root 2, okay. So here already RMS we have here a Vrms value, we have to find Vm. Vm equal to Vrms root 2. Vrms is 100 volt, 100 root 2, okay, and 100 root 2 value is how? Root 2 value is 1.4, okay, 1.40 or 140 volt, okay. Vm is equal to how much? 140 volt. Now we have to find peak to peak amplitude. Peak to peak amplitude means what? Peak to peak means this peak we have to find from here to here and from here to here, means this Vm plus this Vm, okay. Peak to peak to peak, peak to peak is 2 Vm. So 2 into Vm is how much? 140 volt, so total 280 volt. Option B is the right answer. The impedance of television coaxial cable is. So impedance in television coaxial cable, what kind of cable is used in television? It is RG59 cable. The name is RG59 cable and impedance is 75 ohm. An unwanted signal that enters the transmitted signal which cannot be controlled is called noise signal. Unwanted signal is what? Is noise signal. Hartley oscillator. Hartley oscillator is a high frequency oscillator because it uses up to 30 megahertz. Up to 30 megahertz frequency it uses. That's why Hartley oscillator is high frequency oscillator. Negative feedback amplifier. Negative feedback. If we talk about negative feedback amplifier properties, then in negative feedback amplifier, it reduces gain. It reduces gain. Okay, negative feedback, it reduce gain. It increase stability. It increase bandwidth, and it reduce distortion. So in negative feedback amplifier, it reduce gain, increase stability, increase bandwidth and reduce distortion. So in this option only what it increase stability, it is given. So option A is the right answer. Now the frequency range of AM radio. The frequency range of AM radio is 535 kilohertz to 1065 kilohertz. Okay, if we talk about this thing 88 megahertz to 108 megahertz, then this is the range of FM. Okay, and this 20 hertz to 20 kilohertz, this is what? This is audible frequency. By this only we can listen all this thing. Ability to act as an amplifier, which operating region is preferred? Okay, so for BJT, bipolar junction, when it will act as an amplifier, so in a BJT bipolar junction there are four type of regions. Okay, there are four types of regions: cut-off region, then saturation region, then active region, active or linear region. Okay, active or linear region, then reverse active region. So four type of region are there in transistor when biasing. So when this emitter base and collector base, so emitter base and collector base, when these are the biasing, so when emitter base is in reverse bias and collector base is also in reverse bias, then it will then this is called cut-off region. When both are in forward bias, then it is called saturation region. When this is emitter base is in forward bias and collector base is in reverse bias, then it is called active or linear region. Okay, when it is in reverse bias, means emitter base is in a reverse bias and collector base is in a forward bias, then it is called reverse active region. Okay, so when transistor is in cut-off region, then it is used as a application. We will see the applications. So when it is in cut-off region, then a transistor act as a off switch. Okay, and when it is in saturation region, then it will work as a on switch, and when it is in active or linear region, then it will act as an amplifier. And in reverse bias there is no use of this one. Okay, not in use. Okay, so these are the regions and biasing, in which bias what it will perform, like this table is there. So you have to remember all these things. Any question will come in the exam. Okay, so in this question it's asked BJT act as an amplifier. So when it will act as an amplifier? In linear region, means active or linear region it will act as a amplifier. Option D is the right answer. If the number of turns in a coil is doubled in the same length and area, the inductance L will be. So inductance L, if we see the formula for inductance, so L equal to what? Mu n square A divided by L. Okay, where this mu is called magnetic permeability. Okay, and this n is number of turns in coil, and A is called area cross section, and this L is called length of coil. Okay, so this is the formula for inductance. Okay, L equal to mu n square A by L. So in this question it is saying number of turns, that is what? That is n is doubled. When n is what? When n equal to 2n, then the inductance will be, we have to find. So if we will see L1, let's L1 equal to what? Mu n is what? We have to put double, means 2n whole square, and this is A, and length and area is what? Length and area is same, so A divided by L, all are same. Now if we calculate, this is 2 to the power 2, that is we can write this is 4, and mu n A by L. Okay, if we see this is n square, so this is same as what? This is same as L, means inductance. This is same as what? Inductance. So L1 is what? L1 equal to what? 4L. So whenever number of turns in a coil is doubled and length and area are same, then inductance will be what? Quadruple. Option B, 4 times it will have inductance. Okay, next. A differential amplifier has differential gain of AD of 100 and common mode gain is what? 0.1. What is the CMRR? CMRR means what? CMRR means common mode rejection ratio. CMRR is common mode rejection ratio, and this ratio is what? AD by AC. AD by AC. This AD is called differential gain, and AC is called common mode gain. Okay, so here we have given differential gain how much? It is 100, and common mode gain is what? 0.1. So we'll calculate from here, this point it will come 1000, so we can write this thing 10 to the power 3. So this is what? Common mode rejection ratio. But in option it is in what? dB. dB means what? Decibel. So how we will convert this thing in decibel? So for conversion in dB we have to calculate like this: 20 log base 10 and CMRR, that is 10 to the power 3. Okay, so now this is, we can write this is 20, and this log base 10 to the power 3. How we can write this thing? We can write 3 into log base 10 to 10, like this. Formula is there in what? In log. Okay, so now this is what? 20, this is into, so 20 into 3 is what? 60, and log base 10 is what? 1. So this is what? 60 dB. 60 dB. So 60 dB, option D is the right answer. Next, what is the modulation index in a frequency modulated signal with a modulating frequency of 500 Hz and frequency deviation of 10 kilohertz? Okay, so modulation index in a frequency modulated signal. Modulation index we have to find in FM. In FM, modulated frequency modulated signal. Okay, so in FM, how we will calculate this modulation index? That is MF. Modulation index is del F divided by FM. Okay, del F means what? Del F is frequency deviation. Del f is what? Del f is frequency deviation, and FM is maximum frequency or modulating frequency. Okay, so everything we have given. Del f is how? Del f yani ki frequency deviation is 10 kilohertz, and FM is how much? FM is 500 hertz. Okay, now we have to calculate this thing. So we can write 10 kilohertz is 1000 and 500. Okay, so 2 times it is what? 20. So modulation index is how much? It is 20. Option B is the right answer. Okay, next, if IC means collector current is 12 milliampere and IB base current is 0.4 milliampere, the transistor would have a DC beta of. Okay, DC beta we have to find. Beta value means current gain we have to find. IC means collector gain. IC equal to what? Beta IB. This is the formula for relation between collector current and base current. So beta is what? Beta is current gain. So we have to find beta value only. So we can write like this: beta equal to IC by IB. Okay, so IC is how much? IC is 12 milliampere, and IB is how much? IB is 0.4 milliampere. So this milliampere cancel, and this we can write 12 by 4 into 10. If you remove this point, then it will come what? 10 it will come. So now it is what? Now 4, this is in 3 times, so 3 into 10, 30. So beta value is what? Beta value is 30. Option D is the right answer. In a full wave rectifier circuit with center tape transformer, if voltage between one end of secondary winding and center tape is 300 volt peak, then PIB means peak inverse voltage. So if we talk for what? Rectifier circuit. So there are 2 type of rectifier. First is half wave rectifier, another one is full wave rectifier. Further, full wave rectifier is divided into 2 parts: center tape full wave rectifier and breeze wave rectifier. Okay, so PIV for half wave rectifier, PIV peak inverse voltage. So PIV for half wave rectifier is VM means maximum voltage, and for center tape full wave rectifier PIV is 2 VM. Okay, and for breeze rectifier it is VM. So you have to remember this PIV for this types of all types of rectifier, because question will come anything. Okay, anything it will come, so you have to note down all these things. So here we have to calculate center tape so center tape PIV is what? PIV is 2 VM. Okay, we have given maximum voltage is 300 volt. 2 into 300 volt, that is equal to what? 600 volt. Okay, so answer is what? Answer is C. Option C is the right answer. Which one of the following addressing technique is used in 8085 microprocessor? Is not used. Okay, not used in 8085 microprocessor. So like microprocessor 8085 have 5 type of addressing mode. 5 type of addressing mode in 8085 microprocessor. So first one is register. Register addressing mode. First one is register addressing mode. Okay, first one is register addressing mode. Second one is immediate addressing mode. Third one is register indirect addressing mode. Fourth one is direct Fourth one is direct addressing mode. Direct addressing mode. And last one is implicit addressing mode. So there are 5 type of addressing mode in 8085: register addressing mode, immediate addressing mode, register indirect addressing mode, direct addressing mode, and implicit addressing mode. In these options, option D is relative mode. This relative mode is for 806 microprocessor. So here, which is not used in 8085, that is relative mode. Answer D. Okay. Next, a diode whose terminal characteristics are related is this one, and where Is is the reverse saturation current, and Vt is thermal voltage, that is equal to 25 millivolt, is biased at Id equal to 2 milliampere. Its dynamic resistance. So we have to find what? We have to find dynamic resistance. So dynamic resistance or AC resistance, both are same. This is RD. RD means dynamic resistance or AC resistance, that is equal to eta Vt by Id, where this eta is here Vt is thermal voltage, and Id is what? Id is drain current. Id is drain current, and this eta is called recombination factor. Recombination factor. Okay, this is what? Recombination factor. So eta value for, if you see eta value means recombination factor for silicon, so it is what? It is 2, and this is for germanium. Eta value for germanium, it is 1. Okay, so you have to remember this thing also. In question, if they are not mentioned, either semiconductor is in silicon or germanium, then you have to assume like this is germanium only, means you have to put eta value is 1. So here we will put, because here it is not mentioned either it is germanium or silicon, so we'll assume it is germanium only. So eta is 1, and thermal voltage is how much? 25 millivolt it is given, and Id, drain current, is 2 milliampere. Okay, so this milli cancel, so we can write 25 by 2, 25 volt by 2 ampere. So 12.5 ohm is the answer. 12.5, that is option B is the right answer. Next, so according to star connected system, the line voltage in 3-phase circuit is, okay, so 3-phase circuit, in 3-phase circuit there are 2 type of connection are there in 3-phase circuit. In 3-phase circuit there are 2 type of connection are there. First one is star connection and delta connection. So for star connection, first we will talk about star connection. So in star connection, line current is equal to phase current. Always remember this thing, like in star connection, line current is equal to phase current, and line voltage is equal to √3 of phase voltage. Okay, line voltage is equal to √3 of phase voltage, and this √3 means what? √3, the value of √3 is what? √3 is what? 1.732. The value of √3 is 1.732. This is P, means voltage phase. Okay, line voltage is equal to 1.732 of phase voltage in star connection. And for delta connection, again delta connection, line current is equal to √3 of phase current. Okay, here opposite, it will be what? It will be opposite, that is equal to 1.732 phase current. Okay, and what? Voltage line voltage is equal to phase voltage. So it will be what? It is always opposite. So this is the relation between line current and what? Line current and phase current, and line voltage on and phase voltage. So you have to remember this thing. Okay, this is also important for your exam. So here what they ask, star connected system. So star connected system in three phase circuit, it is what? 1.732 times of phase voltage. Okay, this one. So answer is option A. Okay, next. An operational amplifier possesses. So operational amplifier means what? Op-amp. Okay, we can write as op-amp in a short. So op-amp, some ideal characteristic or you can say property, some ideal properties are there for what? Op-amp. So this is what? In op-amp, always remember input impedance. Input impedance is always what? Infinity or always high. Input impedance. Okay. If we talk about output impedance, so output impedance is always low or 0. Okay. And open loop gain. Open loop gain, that is AOL. Open loop gain is infinity or high. CMRR. Okay. If we talk about CMRR, common mode rejection ratio, so it is also high. And bandwidth is also what? Also it is high. So this is the ideal property for op-amp. You have to remember all these things. Okay, see, whatever I am solving the question now, in every question some explanation is there. So don't think like I put this question, so this question only they may ask this type of question. They may be asked according to this whatever explanation I am giving, from that only they will give, they can put question also, like they will ask in op-amp what is the value for CMRR, like that question will become. So okay, so you have to note each and everything whatever I am saying and whatever I am writing. Okay, so here what they according to option, if you see in option, it is input resistance and output resistance only they are talking about, Zi and Z0. So here Zi is input resistance is always high, so very large input resistance, very large output resistance, this is wrong. Small input resistance, this is wrong. Large input resistance, very small output resistance. So option C is what? Option C is the right answer. Okay, next. So a semiconductor is uniformly doped with Na acceptor and Nd donors. Let the free electron and hole concentration be N and P respectively. Assume that the semiconductor is at thermal equilibrium and that 100% ionization has taken place. Then which of the following is true? Okay, so here Na means what? Na means acceptor and Nd is what? Donor. N is electron concentration and P is hole concentration, and here it is mentioned like the semiconductor is at an thermal equilibrium. That means there are no variation in temperature. Okay, so remember this thing, like in any semiconductor, either it is N type or P type, so semiconductor always is in neutral mode. Okay, so one principle we have that we call charge neutrality. Okay, we call charge neutrality. So according to charge neutrality, total positive charge is equal to total negative charge. Okay, total negative charge, this is called, this principle is called charge neutrality. Okay, so total positive charge. Donor concentration, what? Donor concentration means what? Nd. Donor concentration means what? Nd. Okay, donor concentration is what? Nd. It will it is donate charge, it donates charge, so it is always in what? Positive charge, it is in positive charge. And acceptor which accepts charge, so it is in negative charge. Okay, another things, electron, that is equal electron concentration, that is N having always what? Negative charge. and P means Hall concentration having positive charge. Okay, so if we put this thing in this principle, total positive charge equal to total negative charge. So positive things is what? Nd, and plus what? P. Okay, this is equal to what? Total negative. Total negative means Na, negative charge is Na, and electron plus Na. So this is charge neutrality for what? Semiconductor. So here this is asking this thing only. So option D is the right answer. Okay. Now in a uniformly doped abrupt p-n junction, the doping level of the p side is 10 times the doping level of n side. The ratio Wp by Wn of the duplication layer within the p and n region respectively is. So p side. Okay, so p side means what? Doping level in p side. Doping level in p side means what? Na. P side means Na, acceptor. And doping level of n side. N side, p side. P side means what? P side means Na, or n side. N side means what? N side means donor. That is equal to Nd. Okay, that is Nd. So here in a question, what they are mentioned, like the doping level of the p side, that is Na, p side Na is 10 times of doping level of n side, 10 times of Nd. Like this it is mentioned in the question. So we have to find ratio of Wp by Wn, means width. So if we see the relation between relation of widths in p and n region, relation of width in p and n region, in p and n region, so it will be like this: Wpna equal to Wnnd. Okay, this is the relation of widths in p and n region. Okay, so we can modify this thing. We can write like this: Wp by Wn equal to Nd by Na. Like this we can write. We can like this. So Wp by Wn, that is equal to Nd, and we have Na value is what? 10 Nd. So here Nd cancel, and we can write 1 by 10, that is equal to 0.1. Okay, so we have to find this thing only, Wp by Wn. So it came 0.1. So option A is the right answer. Okay, next, in bipolar transistor biased in the forward active region, the base current is Ib equal to 50 microampere and the collector current is Ic equal to 2.7 milliampere. The alpha is, we have to find alpha. We have given Ib and Ic, we have given, we need to find what? Alpha. Alpha is what? Alpha is current amplification factor. Okay, or current gain we can say alpha. So alpha, what is alpha? Alpha formula is what? Alpha equal to Ic by Ie. So we have given Ic value. Ic is 2.7 milliampere, but we don't know Ie value. So calculate first Ie value. Ie equal to what? Ie equal to Ib plus Ic, and this is called transistor equation. Okay, so Ib equal to how much? Ib is 50 microampere and Ic is what? 2.7 milliampere. Okay, so we can write 50 into 10 to the power minus 6 plus 2.7 into 10 to the power minus 3, that is equal to, this is 2.75 into 10 to the power minus 3 or 2.75 milliampere. Like this it will come Ie value. Now we will put in alpha. Alpha equal to what? Ic by Ie. Ic is 2.7 milliampere and Ie is 2.75 milliampere. Okay, milliampere can cancel. So it will come 0.982, and this is what? This is alpha value, 0.982, option C. Okay, here you always remember one thing, like alpha and beta. Alpha is always less than 1. Okay, alpha value it will always come less than 1, and beta value, beta is always be greater than 1. You have to remember this thing. Okay, in option by mistake here these three are like below 1. In option it will like give you less than 1 and all options are greater than 1. Then you directly without solving you can put that option. It is a answer. Okay. Probability that an electron in a metal occupy in a Fermi level, the Fermi level at any temperature is. So Fermi level F of E equal to 1 by 1 plus E and EF divided by KT. Okay. So it is what? It is always in any temperature it is 1 by 2, that is equal to 0.5. Option C is the right answer. When a lossless transmission line is terminated by a resistance equal to surge impedance, then what is the value of the reflection coefficient? Okay, terminated by a resistance, that is equal to what? ZL, load impedance equal to surge impedance, that is characteristic impedance, that is Z naught. So whenever ZL equal to Z naught, then he is asking what is the value of reflecting coefficient. Reflection coefficient means we can represent by like this, rho equal to ZL minus Z naught divided by ZL plus Z naught. This is the formula for reflection coefficient. So we'll put ZL minus ZL divided by ZL plus ZL. So it will come 0. So reflection coefficient is 0 whenever ZL and load impedance equal to characteristic impedance, then reflection coefficient is always 1. Okay, always 0. So here option C is the right answer. Next, if lossless line is terminated with a load impedance 40 plus J30 ohm, then the characteristic impedance of line for minimum possible standing wave ratio SWR will be SWR. SWR means what? Standing wave ratio. Okay, so here we have given ZL means load resistance, we have given 40 plus J30 ohm. Okay, so it is asking SWR for what? Minimum possible value. If you see the range for SWR, so it will be 1 and infinity. So minimum value for SWR standing wave ratio is 1 and maximum value is infinity. So here it is asking for minimum possible value. Okay, so what SWR is 1. Okay, so whenever SWR is 1, that is minimum, then always it is what? Z naught equal to ZL, means characteristic impedance is equal to load impedance. Whenever SWR is 1, then characteristic impedance is equal to load impedance. So here load impedance we have already given 40 plus J30 ohm. So this is load resistance equal to characteristic impedance. So the characteristic impedance value is what? 40 plus J30 ohm, which we need to calculate. Okay, but here options are is in ohm, so we have to solve this complex value. How we will solve? By putting square root of magnitudes. So 40 square plus 30 square, 40 square plus 30 square. So it is how much? 1600 plus 900, that is equal to 2500 or 50 ohm. So answer is what? 50 ohm. Option C is the right answer. Okay. Next, which one of the following is not a vectored interrupt? Okay, interrupt signal. If we see interrupt signal in microprocessor, so there are 5 type of interrupt signal in microprocessor. First one is trap signal. Second one is RST 4.5, RST 5.5, RST 7.5 and INTR. So this 5 type of interrupt signal is used in 8085 microprocessor, and this trap is called highest priority interrupt signal. INTR is called lowest priority interrupt signal. So vectored interrupt signal means what? Microprocessor which know the location of the signal is called vectored interrupt signal. The location is already defined in microprocessor. That signal is called vectored interrupt, and these are trapped signal RST 4.5, RST 5.5, RST 7.5. This 4 signal is called vectored signal. Okay, and this INTR is called unvectored interrupt signal, because microprocessor in microprocessor the address is not defined, that's why. So here it is asking not a vectored, so INTR is not a vectored signal. Option C is the right answer. 2's complement of binary number 0 1 1 0 1 1 0 1. So how we will calculate 2's complement? First we need to convert this thing in 1's complement. So conversion of 1's complement, you have to just make a inverter like 1. So it is 0, 0 means 1, 1 means 0, 1 means 0, 0 means 1, 1 means 0, 0 and 1. Okay, after that this is what? This is 1's complement. This is 1's complement. Now we have to find 2's complement. So for that you have to add 2. So 0 and 1 is 1. Rest are same. So this is 2's complement. This is what? 2's complement. So this is option B is the right answer. Okay. Next, the overall transfer function from block diagram reduction for cascade block is. The overall transfer function from block diagram reduction for cascade block, like cascade. They are asking for cascade. What? How reduction we are doing for block diagram. So suppose 3 blocks are in cascade. Okay, 3 blocks are in cascade means they are in series. Okay, this is what? B1, this is B2, B3 means block 1, block 2 and block 3. Here gain 1, gain 2 and this is gain 3. So if we calculate, this is input side, this is output side. So transfer function, for reduction of transfer function, generally what we will do for overall gain will do multiplication of all the gains, G1, G2 and G3. G1 multiply with G2, G2 multiply with G, means production of product of all block. Okay, so this is what? Option B, product of individual gain. Option B is the right answer. For the block diagram given in the following figure, the expression of C by R means we have to find transfer function. Okay, transfer function we have to find. Here like question, something is missing. Here it is negative, here it is positive, and might be it is visible. This is G1, G2 and this is G3. Okay, and whenever feedback is not there, you have to consider this is what? This is 1. Feedback is 1. Okay, so this is negative feedback is going on, so it is what? It is negative feedback circuit. Okay, so for what? Gain for negative feedback, if we calculate gain for negative feedback circuit, then gain formula is A equals to G of S divided by 1 plus G of S and H of S. H of S means what? Feedback. This is what? Feedback signal. Okay, so this is for negative feedback. When it is positive feedback, then this plus is changed in minus only. Okay, the formula will be for positive feedback, it is G of S divided by 1 minus G of S H of S for positive, but for negative it is plus. Okay, now we have to calculate GS. GS is how much? GS is, it is G1 G2 divided by 1 plus G of S, and H of S is how? H of S is 1. Okay, so G of S is G1 and G2. H of S is into 1. So if we reduce this block, then we can write G1 G2 divided by 1 plus G1 G2. Okay, then another block already in a question, it is what, G3. Okay, so this reduction we can write like this is RS and this is what, this is CS. Okay, now if we calculate transfer function equal to what, C of S divided by R of S. So we can write, in previous question already we have seen, when blocks are in cascade then we will multiply. So G1 G2 divided by 1 plus G1 G2 into what, G3. Okay, into G3. So this is our answer only. This is option A is the right answer. Okay, like this we can we do block diagram reduction. The closed loop gain of the system shown in the given figure. So again here a negative sign, this is positive sign, this is what, this is -3 and this is 0.5. So we have to find gain. Okay, again it is what, negative feedback, because here negative signal is negative feedback is going on. So negative feedback we have to find gain, that is transfer function of C of S divided by C of S, transfer function C of S divided by R of S. Okay, so we'll put our formula. What is negative for negative feedback? Transfer function formula means we gain formula is G of S 1 plus G of S and H of S. Okay, here G of S is how much? It is -3. This is G of S, so -3, and 1 plus G of S is -3 and H of S is 0.5. So we need to calculate this thing. -3, 1 minus, it is 1.5, and -3 divided by, this is what, -0.5. This minus minus cancel, this point it will come like this. So 5, this is 2, so it will come how much, 6. This is come 6. So option C is the right answer. So like that you have to calculate for loop gain. Okay,
expect in your exam. So those who have taken till now these PDF sets of your this question PDFs, so just not only focus in your question, whatever question I gave and related to detailed solution I gave, from detailed solution you try to make questions, and like that you make notes, and like that you prepare this PDF. So you will cover more questions. Apart from these questions, from detailed solution, you will get some more questions. Okay. And those who haven't taken this till now, this PDF, just take this PDF. Here you will get 5 set of question PDF with details explanation. These are based on your exam pattern and previous year question. And this is your important and expected questions. If you complete this 5 set of PDFs, you are going to cover 500 plus questions. Okay. So if you want this, just message me, WhatsApp me in this number and get these PDFs. Okay. So till then, if you like this video, just hit like on a button. If you kindly share with your friends, and if you're not subscribed my channel, just subscribe the channel and press bell icon for notification. Okay. Thank you.